Hello, everyone. I have slides, I swear. Hi, I'm Eyal Sivan. I'm the head of strategic platforms for CIBC, a major Canadian bank. Right out of the gate, I apologize for my raspy voice. I'm coming off a bit of the flu. If I start coughing up here, please excuse me. If I faint, just stuff me in a cab and send me to the airport. So I'm here to talk to you today about the rise of the service mesh. It was a coincidence the talk was called Rise before I knew the theme of the conference. But what the heck is a service mesh? If you haven't heard about it from your customers, you're absolutely going to, I promise you. And I'm here to sort of tell you a little bit about what it is, where it came from, what does it have to do with microservices, what does it have to do with APIs. And it's a big part of my personal journey. I've been in front of CIBC's integration efforts for the last 15 years. And I'm here to tell you about that story. Thank you to the Axway team for inviting me to speak today. So what the heck is a service mesh? How did we get here? APIs are so hot right now, right? Everybody's selling all these amazing solutions for these sexy new things called APIs. But wait a minute. As everyone in this room knows, APIs are nothing new. APIs have been around since software's been around. Been around since the 60s and 70s, and all an API is, application programming interface, as you all know, is just how you get pieces of software to talk to one another. Now, when software was first introduced in the 60s and 70s, you did it however you could. You would take these giant monolithic applications and connect them together in whatever way the coders who built those applications offered you. This could be comma-delimited files or EDI or other weird, obtuse, proprietary formats, but you would just sort of mush them together. And for a good couple of decades, that worked. That's how software worked. You would tie monolithic applications together through proprietary APIs. And then around the late 90s, early 2000s, something really cool happened, something called service-oriented architecture. Now, at this time, I was a young kid, had my own little 90s startup specializing in integration. And it was during this transition that I was brought into CIBC as like the whiz kid, right? The web services superstar is going to show them the new way of building APIs. And I introduced them to technologies like SOAP and XML, and this radical notion of defining APIs based on industry standard technologies and contracts. Prior to that, it was all proprietary. And then along comes service-oriented architecture and says, I've got a way for you to define APIs that looks the same. It uses the same technology for every system. And I'm going to give you this amazing broker in the middle called an enterprise service bus that's going to separate consumers and providers for the first time and allow them to run independently on independent development cycles that operate at different speeds. And I can automate your testing, and I can radically increase your efficiency. And that was a big deal, right? They liked this whiz kid coming in telling them, wow, cool, standardized contracts, what an amazing idea. Now, I'm very proud to say CIBC is one of the few organizations that can raise our hand and say our SOA practice was successful. Not a lot of folks can say that. SOA got a lot of bad press. People said, spent millions of dollars, didn't see a benefit. Now, a lot of that had to do with folks misunderstanding why they were doing SOA. We kept our approach very light, very purpose-built. We were very clear on our syntactic versus semantic distinctions for the geeks in the room. And that worked pretty well for like a decade. But then something really interesting started to happen. Folks wanted the bus to do more. They wanted it to do logic. They wanted it to do if-then checking. They wanted to add trailing zeros to payloads. And we kept saying, no, you can't do that. Syntactic versus semantic. Don't pollute the bus. It's this nice, skinny, appliance-based bus. Don't mess with it. But we hear you. You want the ability to have that consumer-provider separation and the flexibility of having a broker that you can sort of play with and mess with. And along comes a new kind of pattern called federated SOA, federated service-oriented architecture. And the way we approached it was we said, we're going to keep our bus, we're going to keep it pure, the enterprise bus, but we're going to give each group their own little bus. And we called it a domain service bus. And we gave this domain service bus to the different business groups and said, you want to do logic on your own little domain bus, go ahead. So they started adding the trailing zeros and adding the if-then loops while this enterprise service bus was clean. And that worked pretty well for a few years. We were very proud of ourselves. We solved the classic SOA problem. The SOA problem, for those who are not talking about this stuff back then, was monolithic. You have a pile of spaghetti. You'll inevitably see the before picture as an architecture diagram that has a whole bunch of boxes with tons of lines flying all over it. Spaghetti. And the promise of SOA was the bow tie. Put this thing in the middle, and it's going to create this amazing, beautiful architecture diagram where everything just ties together through these standardized contracts. Much more efficient, major cost savings, much clearer picture of your IT systems, rational, less redundancy. Worked pretty well. And then the wheels came off the bus, pardon my stretched metaphor, right? Right around the sort of 2010s-ish, APIs changed. Something radical happened. Suddenly they're popping up everywhere. They're popping up closer to the glass, up where the channels guys are building UXs. They're popping up at these new startup companies that are offering rapid ways to launch apps on smartphones. This new kind of API collectively came to be called web APIs. And I had my boss at CIBC coming up to me saying, well, what the heck is this? These things are off our radar. They're not on our bus. In fact, they don't even use SOAP and XML. They're using these new things, REST and JSON. What the heck is going on? So I'm the whiz kid, so I went and did some research, right? Now, I started reading these papers, trying to read, what the heck is going on? What are these new APIs? Why are they different? I thought, no big deal. Replace the XML with JSON, replace the SOAP with HTTP and REST, and everything will be fine, right? No. Turns out I was wrong. I start reading about what's happening, and all these papers are referring to me as a dinosaur. I don't want to be a dinosaur. They say anybody who's doing service-oriented architecture, you're clearly an old man. And I was hurt. I was personally hurt. I was the whiz kid, and here I am, an old man, and I could not stand. I have to understand what the heck is going on. And this led me down an incredible road where I started to learn not just about what was happening to APIs, but what was happening to software. And tied up in this whole story of the evolution of integration was the role of the gateway and the identity crisis that gateways were going through. One of the first things I realized was when you started to look at the term API gateway, it meant different things to different people. And you'd have solutions that were radically different from each other, both calling themselves API gateways. So you'd have, on the one hand, something like Mule. I'm allowed to say it. I don't work for you. MuleSoft. So you'd have things like MuleSoft that would call themselves API gateways. And then you'd have things like Nginx that would call themselves API gateways. But just the most cursory look at these solutions would tell you they are not remotely the same thing. So what was going on? When I started to drill into the category of full-featured, highly functional gateways like MuleSoft, I realized that I've heard this story before. It's a story that today, by several companies, is still called API Gateway. Not so long ago, by MuleSoft themselves, it was called Enterprise Service Bus, the bad kind. Not long before that, it was called EAI. And not long before that, it was called ERP. I like to call that pattern the magical black box. And it is the ultimate bow tie. The idea being, take all your systems, hook them into my magical black box, and all your problems will be solved. Just solved. Don't worry about it. Here's my collection of adapters, and once you hook your adapters into all of your systems, and you give full control over to my incredible magical black box, I will solve all your integration challenges, your business process challenges. Look at this amazing visual tool your managers can use to create all of their workflows. You can basically fire all of IT. You don't need them anymore. You have the magical black box. The thing is, I've been in this business for 25 years. The magical black box is a lie. It never works. It doesn't work by any name. All you end up with is a giant proprietary bowl of spaghetti. And the next thing you know, You're hiring expensive resources who are specially trained, often directly from the vendor. You're trying to figure out why you're experiencing performance problems, why the thing won't scale, isn't compatible with all the other tools you're buying, and the next thing you know, you're spending millions of dollars just to pull out the damn thing that you spent millions of dollars putting in. The magical black box doesn't work, and it especially doesn't work today in our rapidly changing world. So what do? What does CIBC do? What do I go to my boss and tell him that, I've learned this new thing? And rather than going with this centralized traffic cop, single point of failure gateway approach, we took a different approach. We adopted a pattern known as the distributed gateway. Now, a distributed gateway pattern essentially says, I'm gonna take what a gateway does out of this central controller, and it's worth spending a minute on what does a gateway do. A gateway does what are known by engineers as cross-cutting concerns, which is a fancy way of saying things that all applications have to do: security, telemetry, observability, circuit breaking, and a host of other functions. The point is, you don't want coders writing that stuff. You want some sort of tooling that's going to give it to them for free so that they don't have to worry about the intricacies of these cross-cutting concerns. So a distributed gateway pattern says, pull all that cross-cutting concern stuff out of your central controller, package it into something really, really small, and then wrap each of your microservices in this tiny gateway. So instead of having one traffic cop, you now have a whole bunch of little tiny gateways all cooperating together. Now, I know the geeks in the room know 3 slides ahead exactly what I'm going to say, microservices and so on, but bear with me. To understand what the distributed gateway pattern works, you have to understand what a microservice is. So let's talk about APIs versus microservices. Now, you'd be surprised by how many people still, after all these years of modern APIs, conflate these two concepts. They are not the same thing, okay? APIs are the contract. APIs are an agreement. They basically say, if you send me this input data, I'm going to send you this output data. That's what they've said since the 60s. That's what they do today. It doesn't matter what technology you're talking about. That is what an API is. It's an agreement that says, send me this, and I'll send you that. Follow my rules, and this is how I will respond. There is no code in an API. Okay? There's nothing running in an API. It's just the interface agreement. What you're talking about when you start to discuss code and logic and execution and runtime is the implementation. What's going on under the API, under the hood. Microservices came along and offered a radically new way to deal with the implementation. Now, I could start getting into technical definitions and on, but I think the best way to explain the difference between APIs and microservices is by example. Let's say you've got a 40-year-old mainframe, some honking piece of iron, and it runs your core banking or whatever it is. And that mainframe does 10 functions. You could put some sort of adaptive layer in front of that, a fat gateway, a skinny gateway, that would expose those capabilities in the most beautiful APIs you ever saw. REST, JSON, GraphQL, gRPC, beautifully written, beautifully documented, self-discoverable, all the wonderful trappings of a modern API. And you know what? You would gain genuine developer productivity. Developers who wanted access to those 10 functions would be able to read those APIs and go, wow, this is pretty great. I know how to use this. I can integrate with it easily. I'm a happy developer. I am a delighted developer with this beautiful developer experience using these marvelous APIs. But those developers are going to start asking for things. They're going to start asking for changes to those APIs. And they're going to say, hey, that 10th function, I need another field. Can you give me one more field? Just one more field. Surely that's trivially easy. Or that 9th function. Turns out we're doing some big promo on Black Friday, and we need to hit that 100 times more than we usually do. Can you boost the performance on just that 9th function? Your answer is going to be, wait 6 months. It's a 40-year-old mainframe. We run on 6-month or 1 year or 2 year or never release cycles on that honking 40-year-old box. We can't touch it. Adding a field is like a huge project. And even if we could add that one field trivially, well, now I've got to repackage the whole thing, regression test, deploy it. Now it's massive. I've got to figure out a way to package this multi-gigabyte container, et cetera, et cetera. It's a monolith under the hood. So the best APIs in the world are not going to help you. What do microservices do? Well, microservices say, take those 10 functions, and instead of having them run as a single gigantic monolithic application, have 10 tiny applications. Now, to a layman, that's like, yeah, obviously. But frankly, the technologies that made that possible only showed up on the scene a few short years ago. So how does that look? Well, instead of now having this one giant monolithic application, you implement each of those 10 functions as a tiny self-contained microservice. In that microservice, it has everything it needs to run, from operating system to web server, all the way up to the actual API that it's exposing. Now, when those developers come along and say, hey, that 10th one, I need a field, go, no problem. Add the field to that individual microservice, don't touch the other 9. You need to scale up one of them individually, no problem. You tell Kubernetes to scale up just that one service, you leave the other 9 alone. Moreover, you can now run each of those microservices on their own CI/CD cycles, on their own timing, and you've essentially broken down the monolith. What I learned was that the key to speed is not APIs, it's microservices. APIs might give you developer productivity, but microservices give you speed. The thing is, microservices themselves are on a bit of an evolutionary journey. Like all things IT, they're not standing still, they're changing constantly. So when they first came along, I talked about this earlier, there was the monolithic approach to the cross-cutting concerns. You'd have these large gateway vendors come along and say, this is the way to manage microservices. Drive all the microservice traffic through my big gateway. Now, anybody who was really looking at this seriously would realize, whoa, that doesn't jive. There's something clearly out of step between the architecture you monolithic gateway providers are trying to sell me and the whole principle of microservices in terms of not having choke points, et cetera. And that's the reason why the big boys, the Googles, Ubers, Netflixes of the world, would never touch one of these monolithic gateways with a 10-foot pole. They absolutely would never, ever use them. But they still had cross-cutting concern problems. So what did they do? Well, they adopted the distributed gateway pattern, but what came to be known by another name, microservice chassis. And the approach here was, well, I'm going to create a series of libraries. Remember the distributed gateway? Well, they created a gateway as a series of libraries, and they would tell their developers, hey, all of you have to include this gateway library inside of your microservices. Out of these big boy shops, you'd see things like Hystrix and Finagle and homegrown frameworks that they would use to implement this distributed gateway. In the enterprises that you often deal with, you'll hear about Spring Boot. So Spring Boot is probably the most common implementation of a microservice chassis pattern. Probably not the most advanced, but a legitimate implementation of a microservice chassis pattern. And that worked for them pretty well for a while until they realized a classic problem with software development. Libraries are a pain in the ass. Managing them, dealing with versioning, making sure your developers are using the latest one, making sure you support all the languages that your developers want to use. And then even if you get all that right, every time you make a change to the framework, to the libraries, you have to make your developers recompile their applications and redeploy them. Really unwieldy. Big scale problems. And for enterprises that aren't the Googles and the Netflixes and the Ubers of the world, it is almost unmanageable. It just becomes way more complex than is worthwhile. So some of them just stuck with the sort of monolithic approach and said, wow, this microservice chassis stuff is too hard. But then something new emerged. It was known as the service mesh. And some smart folks at Lyft, of all places, along with help from Google and IBM and Red Hat, said, well, wait a minute, these are microservices. I can just pull out that library and sort of create a whole other microservice that sits alongside my master microservice and acts as a kind of proxy. So that every microservice has its own tiny little proxy. Those proxies came to be called sidecars, right? Very clever. The microservice is the motorcycle and the proxy is the sidecar. And this collection of intelligent proxies together came to be known as the service mesh. Now, it's worth noting that it's not over, right? Microservices continue to move, and over the horizon, we can see something called serverless, which does away with packaging entirely, and you're essentially deploying raw source code. But serverless is not really ready for prime time. It's often proprietary, tied into an individual cloud provider, and has a long way to go in terms of maturity. But Service Mesh absolutely exploded. It went from a little-known couple of open-source projects to now several commercially viable, supported by big vendor implementations. And again, remember my opener, if you have not heard about Service Mesh yet, I promise you, you will very soon. So where does Axway fit into all this? When I first did this analysis a couple of years ago, that's where you guys were, right? You offered a centralized gateway solution. And you sort of said, push all your traffic through our traffic controller, and we'll do what we've always done. But again, that's sort of out of step with microservices architecture. Now, what I've been really impressed by over the years, speaking to people like Chris McCauley and more recently Vince Padua, is that this has happened, right? Axway has really jumped into this new world with both feet. You've put enormous work into maturing your platform and really embracing this idea of service mesh, and doing it in a particularly unique way, which I will talk about a little more later. So, what is a service mesh? Right, again, the geeks in the room who know this stuff, you can just check your Slack channels or whatever. But for the sales guys, if you're going to be asked this, I want to make sure you're armed and you know what it is. So let me give you the quick tour. A service mesh is a collection of microservices, each of which have a sidecar proxy. That basically means that the cross-cutting concerns are all contained in this tiny microservice that runs right alongside it. In technical terms, it runs in the same pod in Kubernetes. All of these proxies communicate to each other point to point. This is what is known as east-west traffic, or internal traffic between microservice to microservice. This was sort of the whole pitch of service mesh. You don't want to handle your east-west traffic the same way you handle your north-south traffic. North-south traffic is still handled through a perimeter gateway that deals with scenarios where you're leaving your trusted network. So a lot of B2B stuff is still done through a perimeter, but the perimeter now becomes very, very light. It becomes based on very lightweight gateway clusters, often based on Nginx technology and others. Yes, you can continue to use Axway as a perimeter gateway. All of these proxies, the policies for the proxies, are controlled through something known as a control plane. Strictly speaking, things like Istio that market themselves as a service mesh are control planes. They control these proxies and basically pass policy instructions down and do other things like integrate with metrics tools. This whole thing runs on a container orchestration environment, typically Kubernetes, or OpenShift, if you're more prone to the enterprise variety. And the final touch is you're still going to probably organize your microservices into logical groups based on domains. You may apply a design methodology known as domain-driven design. But the important part is you're never creating those domains in a physical sense. So you're not doing anything to your microservices that physically bind them to domains. These are basically arbitrary groupings. So it's very soft. Your service mesh is generally on a flat network, and this is the architecture that gives you this wonderful sweet spot between, on the one hand, distributed policy enforcement and a truly distributed microservices architecture, but on the other hand, a single control plane, centralized management, a single pane of glass that allows you to control the behavior of your mesh. So you can effectively have your cake and eat it too. Now, can this be done, right? Is this crazy pipe dream stuff that only Google can do? Absolutely not. At CIBC, this is exactly what we did. We started off by adopting an open source project, bringing it in-house, putting a bit of a team around it, and bringing that open source project up to enterprise scale. That open source project was based on the microservice chassis pattern, but based on the feedback we were getting from our internal groups, we holistically matured it to something that looked a lot like a service mesh. We took the chassis out of our code generator and effectively started to deploy proxies. We're so proud of this architecture, the team and I that put it together. I'm the platform owner for the product, because it was so different than what our competitors were doing. And we actually gained some industry accolades. We ended up winning a couple of awards from Forrester InfoWorld in 2018. And in 2019, we picked up a Celent Model Bank Award for integration, largely on the strength of our API Foundation platform. So it's a wonderful piece of work that we're enormously proud of. And it's entirely open source. Every build we do on the platform goes right back into the open source community. So if any other bank wants to use it, they are free to do so at zero cost, which is pretty unique for a large incumbent bank. But we're sort of feeling a bit of growing pains now. When we started this, service mesh literally did not exist as a term, right? We were trailblazers. Since that time, a lot has happened. Service meshes have matured. There are some serious commercial offerings now. And moreover, there are some really advanced service mesh scenarios that we find ourselves struggling to adapt our framework to support. What can broadly be classified as the multi-mesh problem. Like the multi-mesh problem says, I now have more than one mesh. I have to support multiple meshes across testing environments. I have to support multiple meshes that cross cloud providers. I have to support hybrid integration where I've got some of my systems on-prem and some of my systems remote. And finally, and maybe the biggest, how do I expand my mesh so that it can go beyond Kubernetes? I've got all these legacy systems or heritage systems that have to connect into my mesh as well. And they're running on VMs and God knows what else. So how do I put proxies on those VMs and tie them into the same mesh? At CIBC, we are slowly coming to the conclusion that we probably don't want to be the next Google and continue to develop a platform that's going to do all of this in-house. So we've started looking at some unique vendors in the market that try and address these problems. Vendors like Solo, Console, Nginx. And I'm pretty proud to say Axway. I had a great conversation with Mr. Padua yesterday. And based on what I heard, your team is uniquely positioned to provide amazing solutions in this space. With the work that you've done on Amplify Central, that now works with Istio, works with other service meshes, works with your perimeter gateway solutions that you have now, as well as, of course, MFT, you're positioned to provide a single pane of glass, a single control plane that can give me a view of my entire integration landscape. That's unique. I haven't seen any vendors that can do that kind of stuff. So, of course, there's a lot to the execution. You know, I'm looking to the sales guys. You have to tell this story and get out there and get folks to actually understand the benefit. But I think Axway is in a particularly unique position to provide a solution to this multi-mesh problem. Now, when you're out there selling it, you're definitely going to run into naysayers. You're going to run into people who said, well, why on earth do I need this? We just don't change that fast. Business people ask me for releases every 6 months, right? Why on earth do I have to be this agile and this nimble? Well, I can't speak for every industry, but I can speak for banking, and banking is being disrupted. This is not a question, will we be disrupted? This is happening, right? You heard from the gentleman at Commerce Bank that this is real, right? And it has to do with a number of factors, a number of pressures, one of which is these things, right? We all carry around one of these. These are, in banking terms, pretty new. But now, customers expect the same experience from their banks that they get when they order a hotel room or a pizza or a taxi. They won't stand for anything less. So a massive pressure point is customer expectations. But that's not the only one. Another one is technology companies, both big and small. You've got the GAFAs, who are slowly creeping into financial services, and then you've got a whole plethora of fintechs all over the world that are also sneaking into the world that was once reserved for these masters of the universe. And then the final major pressure is what's come to be known as open banking. This comes in different shapes and sizes, but generally speaking, it's often a regulatory push around the world to say banks have to open up their data via, you guessed it, APIs. So these pressures combined have really driven the pace of change up through the roof. And banks have to respond, which means they need architectures that are nimble enough to support this constant change. This constant change is the new reality. And I'm going to wager that in other industries like telecom, healthcare, industrials, etc., this same disruption is taking place. All this talk about helping companies survive that we heard from Brian, well, it's because of stuff like this. It's because of this digital disruption. Now, what's interesting is this isn't limited to what's happening up in the business strategy world, where companies have to rethink what they do and how they do it, new businesses they're going to get into. It's happening in software as well. The metaphors for IT systems are changing. If you speak to engineers like I do, you'll hear that the language they use to describe IT solutions is changing. For the longest time, IT systems used to be these rigid things based on, well, engineering, architecture, things from the real world. The metaphors you would hear are things like city planning and building buildings, building bridges, plumbing, etc. And the predicate there was you have to get the design right up front. Because if you don't get the design right up front on a bridge, well, people are going to die. I mean, you can't do that, or on a plane. But now the metaphors are changing. They're changing into things that sound a lot more like biological systems. They sound like things like cells, and molecules, membranes. And the predicate there is, these are things that can evolve. These are things that can change and adapt over time. And when you speak to the engineers that think of IT solutions this way, there's a common theme, and that common theme is that they build for change. They know up front that their systems are going to change, and they don't shy away from that. They build them to be evolvable systems. And that world of constantly changing IT systems, systems that can adapt and evolve, is the new world of IT. I'll leave you with this quote from one of my heroes, Martin Fowler, godfather of microservices. He says, "There is no design at the beginning. You begin by coding a small amount of functionality, adding more functionality, and letting the design shift and shape." This is at the heart of the new way of delivering IT solutions. And those organizations that learn to build for change will lead the way. Thank you.